Hi everybody, this is Mr. Brooks, and today I'm going to go over literal equations, and this is in the foundations unit, so this is covered in that unit from geometry and algebra 2. So from the BVLA slides, and we're now kind of coming up where we're doing so much that we need to start thinking about making a new one. But a literal equation is an equation that we use that has more than one variable, or it could be like a formula because formulas have more than one variables. And so it's still an equation, it's just think about it as many letters, okay? And here's an example of not a true literal equation, but I think it's worth thinking about philosophically. A lot of things in life are boiled down to equations. We try to figure out what makes something. And so, curiosity equals wonder plus awe. Anxiety is equal to uncertainty times powerlessness, and happiness is equal to gratitude divided by gratification. I think those are three good ones, and I went through them really quickly, but you can reflect on those if you want. I think, anxiety. So, like, why are people anxious? Well, there's uncertainty. So, uncertainty causes anxiety. And when you don't have control over something, when you're powerless, that causes anxiety. And I like how these are multiplied, as in they really build off of each other quickly instead of adding, because it's not just summative; it really does multiply past itself. And then here's some examples of some equations that change the world. They're really formulas. This is from a book called 17 Equations That Change the World by Ian Stewart. I don't have all 17 here. I just copied and pasted the top 8. And at the top is Pythagorean theorem. You guys probably know that. Logarithms deal with finance and also studying exponential growth, but really it changed the way we bank. Calculus is talking about like a lot of physics and also economics, but really it came into its own when trying to describe, what's happening with the planets and what's happening with like bodies in motion. By the way, that equation you can see is only a few things, and it really, there's f of t and then f of h and then h. So it's very little. Calculus is not terribly hard. The hardest part, or the part that students tend to struggle with, is the algebra. So if you get a chance to go on and see some calculus, I would highly recommend it. It's really cool. When I was in college and I saw how calculus showed me a relationship between position, velocity, and acceleration, it really opened my eyes as to how math explains the world, which, here's all these equations we put in to try to explain our world. Law of gravity has 4 variables in it, you'll see from Newton. And the other one, Euler, is a good one to know. He did a whole bunch of different mathematical concepts, and he was kind of a rock star of his age. Gauss did statistics, and the only one I'm least familiar with is probably J. D'Alembert. Albert. I'm guessing you say his name is French. But wave equation, I know that there's lambda in there, but I've never used that before. But here are some that you are familiar with from geometry, or if you're in algebra 2, you're familiar with them. But area of a triangle, volume, circumference of a circle, all these are literal equations. There's more than one variable, and you guys have dealt with these before. So if you have base and height of a triangle, you can solve for area. And then what we're going to do is we're essentially like thinking, can we rewrite this to solve for the base? If we had the area and we had the height, can we flip it around and put b equals? And that's what this is doing. And it's the same rules of algebra. So here's some that I want to highlight. And these are going to stick with us forever and ever and ever and ever. And so these are really worth like solidifying as our foundations. And this is really the point of this unit, is to get a good foundation for how we're going to take things on when our concepts become a little bit harder. But what you do to one side of the equation, you have to do the other. What you do on the right, you have to do on the left, right? And then use inverse operations to cancel. And you may only add or subtract like terms. So you keep your like terms straight. And then you may distribute or undistribute factors. And you may apply the commutative property. And then follow PEMDAS. So, those 6 I think are really worth getting a solid grip on as we move forward. But here's what it looks like. This is a question from Delta Math, and it says, solve the following equation for A. So here's A right here. That means we need to get A by itself. And we're gonna think about like terms. So we cannot combine things that are not like terms. And we're going to think about inverse operations, because ultimately we're thinking like, is it multiplied, subtracted, divided? And then we're going to do the opposite of that, okay? So in this case, there's a negative b added to a. So the inverse of that would be to add b to cancel, okay? And then the rule is what you do on the right, you have to do on the left. So add b, okay? And then I'm just going to bring down the a. So over here, you have to remember how to use like terms. So you may not combine f and b together. If you put f and b together, it would be f times b, but we're not timesing, we're adding. So you just have f plus b is equal to a. And so just like you said, f is negative b plus a, then a is f plus b. Okay, so you might have done something with math statements where you kept it true, but that's it right there. Okay, so next one. Okay, so still one step, still simple. It says, I'm looking at m cubed, I'm looking at t and b, and so my brain needs to start thinking, aha, I'm doing a literal equation. What do I need to solve for? Because you're not solving for the one variable. It says solve for b. So here's b right here, and what's happening? You might, if you get confused, ask yourself, what's happening to b? Well, we're dividing b by 4 minus m cubed. And so the inverse operation, instead of dividing or to cancel out the division, we're going to multiply. Okay, so instead of divide by 4 minus m cubed, we're going to multiply by 4 minus m cubed. Okay, and then over here we'll write it the same way, 4 minus m cubed. All right. Now, when you divide and you multiply something, it cancels, right? And we know that. And then over here, I could distribute the t, but I don't have to. And for Delta Math, I don't think I know they don't make you, but I think they might not even want you to. But essentially, we're going to take this 4 minus m cubed, and this whole thing is multiplied, right? So we're not just multiplying m cubed, we're multiplying all this. So it's going to be like that, where we put it in a parentheses. And there's not a dot here. I mean, we can put a dot, but we don't need to, so don't worry about it. But if you type it in just like this into Delta Math, parentheses 4 minus m cubed, remember that's where you need your caret. If you want to do m cubed, you have to use Shift 6 to get it, okay? And that's it. Okay, here's one more. And you're looking at this. If this did not have a in both this parts, so literal equation, more than one letter, literal equation, solve for a. Always read what you're solving for. If this did not have an a in both parts, you might have to treat it like a two-step equation and add or subtract off. Like you could subtract off this whole thing right here and bring it to the other side. That is allowed, okay? You can add or subtract the whole term, all right? But that's not what we're going to do for this one, because it looks like a is in both terms. A is in both terms. And we can think about the distributive property. And so it says if you multiply by the number to both parts, then you can distribute it. It is distributed, so we can undistribute it. So I'm going to pull A out of the distribution, and that's going to leave Q plus R squared. Okay. So what I did was I recognized that A had been distributed and I can undistribute it. And then now I read it as A times Q plus R squared. So the inverse of times is divide by that number, R squared. Okay, and then same thing over here, Q plus R squared. And these parentheses. And when you go into delta math, you're going to have to put in these parentheses in order to show it like you're not just dividing m by 9, but you're dividing m by the whole thing. And so this cancels off, and I'm left with A. And then this is the answer right there. Q plus R squared. So that's it. Don't worry about the exponent. You know, you're not going to have to deal with the exponents in this probably. And if you subtract a term with an exponent, you just subtract it and don't bring the whole thing over. And if you multiply it, then you just stick it together. So you know that exponent is just going to hang out there next to the variable. That's okay. All right. Okay.